Welcome to Hardware Asylum. We're once again working on the classic case build. If you're unfamiliar, this is a Magitronic Mini Tower chassis that we've been slowly refurbishing. I was able to do a retrobrite on the front bezel. We fixed the LED display. It used to display 40 and 10. We've changed that to 40 and 20. Off camera, I was able to install the power supply. It now has a Noctua industrial 80mm fan. Nice and quiet, still flows a great amount of air. I was also able to install the motherboard. We did swap it from the 386 40 MHz that was in this build to begin with. I've taken the 386 40 MHz that was out of the scam case. This particular motherboard is very similar to the one that was in this case. It does have support for a 487 DLC math code processor. We have the 386 40 MHz processor embedded on the motherboard itself. And we do have a socket here for a 486 DLC processor expansion. That's the Seagate chip that allows the 386s to have a 486 instruction set. And let's look at what else we will be installing. With every new build, I like to start with laying out the expansion cards that will be installed. First one on the list is a video card. First product will be a ProDesigner 2 from Orchid. It's using a SIMM chip, and this is one of the few ISA-based video cards that allow you to run higher resolutions in certain applications, including Windows 3.1, AutoCAD, and several word processors. All you need to do is install the drivers and enjoy higher resolutions. The next card will be a Sound Blaster 16. This is a card that I've had in my collection for a very long time, and strangely enough, this is the very card that I purchased and installed in my 386 and broke the motherboard. The sound card survived, and we'll be putting it into the classic case build. If this was a proper retro PC build, the next card would obviously be a modem. However, since we don't have dial-up networking anymore in our modern society, I'm going to install this 3Com Etherlink III network adapter. It is ISA based. It comes with a BNC connector, this fancy one that nobody ever uses, and a standard RJ45 jack. This is a 10-base T card, and with the proper drivers, we should be able to get Windows 3.1.1 on the internet. For this particular build, I'm going to install a Teac based 3.5-inch 1.44 meg floppy. We're also going to be installing a 5.25-inch floppy. This is the high density 1.2 megabyte. Also a Teac brand. This is a drive that I've had in my collection for a very long time. And this happens to be the FD55GFR. For storage, we have several options. We could go with something like this, which is an SD card to IDE adapter. This allows you to use any sort of a flash card, including this 32 gig PNY, with a retro machine or anything with an IDE interface. All you need to do is make sure to partition the disk down to match whatever this system is going to support. Or you could go with a standard IDE drive. We have an awesome Seagate drive that came out of this machine that we could put back in. Although I want to take this particular build, at least at this time, into a slightly different direction. And we're going to be using this Microscience HH-1060 RLL drive. I have a note on here saying it's a good drive. I replaced the board. It has some bad spots, and it does do an auto park. There's a slight note down here saying it might be dying, which is a common problem with these old hard drives like this. And I put this note on here because when I would do a scan disk, it would find more and more bad spots. So what I'd like to do is use this drive a bit and see if those bad spots go away, or if the drive really is on its last legs. Now, to run one of these drives, we need to have a controller. I have two of them that I can choose from. The first is an Adaptec. This is a really long, full-length expansion card. Supports 16-bit ISA and is actually a very fast controller. My other option is to use a Seagate drive, and I have them in this box here. I have an RLL and an MFM version. As you can see, it's a much smaller card, and it supports all of the same features. We have an onboard floppy controller, we have our RLL connections here, activity LEDs. It also has an onboard BIOS, allowing you to program your drives on the card itself instead of using the BIOS on the computer. Now, the reason I'm not going to use the floppy interface on the RLL controller is because I need to have I/O. And for that, we're going to use just a standard I/O adapter. This does have an IDE interface and the floppy, but we just need to have a serial port so we can hook up a mouse and maybe a parallel port for printer access a little bit later. Now, since it does have an IDE interface that allows us to run things like a CD-ROM or maybe even this adapter, because our Microscience drive here is only 60 megabytes. And of course, the final item, since we had to remove the onboard battery, is to install an external battery. So now that we have the build laid out, let's put it in the box. The next item will be our RLL hard drive. And since I've been working on this particular drive, I did have to remove the control board. And most of these drives have a paper cover on the back that protects the control board from hitting anything metal. I used this one as a template and was able to 3D print my own. This is 3 layers of PLA plastic, and if you're interested in this particular STL, just leave a comment down below. The next thing to do is we need to take a picture of the defect list, because that will become important when we start to low-level format the drive. And I'll go ahead and leave my sticky note on top. Unfortunately, I didn't retrobrite the front bezel of the Microscience drive, but maybe we can get to that a little bit later. The last item to install will be the 5 1/4 inch floppy drive. In terms of cabling, we need to use a standard floppy cable to connect our 5 1/4 and our 3 1/2 together. The 5 1/4 takes this edge connector, and our 3 1/2 will take the standard plug. To hook up our RLL Microscience drive, we need to use 2 cables. We'll have a standard one. This is the data cable. It has an edge connector on it. And they have what they call the Teac cable, and this is much smaller. It still uses the same edge connector. Those 2 together will allow data to transfer and be able to control individual drives. The only thing we need to make sure is that we hook it up correctly. The color always goes toward the power. Now, with all the cables hooked up, we can connect them to the board. I'm going to go ahead and install the sound card at the very bottom in the last, almost the last slot. Ethernet card will be directly above it. The last bay needs an expansion slot cover. And the video card will go below the I/O controller. And then we'll need a slot cover to fill it up. Now, the scariest part of any retro build is the first startup. And I'm going to record just in case we have a lot of smoke. Success! It's been a couple of days, and I'm happy to report that the classic case build is working perfectly. Now, according to the Seagate documentation, the RLL controller needs to be set as a secondary controller. That will allow the machine to boot up using the IDE interface so that the BIOS can talk to that controller and allow you to configure hard drives and the floppy drive connection. Then the onboard BIOS on the Seagate controller will take over, find the hard drive, and assign a drive letter to it. Now, if I don't have a hard drive plugged into the 40-pin IDE connection, I can boot off of the Microscience drive. However, with 66 megabytes of space, you quickly run out unless you want to just run DOS programs. I would like to use some DOS stuff for DOS games, and I would also like to be able to install some Windows 3.1, get on the internet, and so on and so forth. So, one of the storage methods that I really like using on retro PCs like the classic case is this SD card to IDE adapter. To get one of these devices to work inside a computer, you need to put this in a case. So I got on Thingiverse and found this, which is a bracket supporting the SD to IDE adapter and allows it to be installed into an expansion slot in your computer. The one issue I have with this is that this is a plastic representation of something that should really be made out of metal. It flexes a lot, cracks, and while the dimensions are perfect, when I did install it, I found that when I was inserting the cards, everything was flexing really, really bad. So I've remixed it into this particular design. Of course, I needed to put the Hardware Asylum logo on here just to represent, but I added some proper reinforcement, so now it does not flex. Unfortunately, the standoffs are not tall enough, so I cannot put a brass insert in there, but the plastic is thick enough around here that I should be able to just use some standard case screws. And even with just 2 screws in here, it's firmed up a lot. It does not flex. It's very solid. Should work perfect.